we're going to do the solution for week 8's challenge. The first thing we're going to do is we're going to clone the repository. You don't need to fork it this week because you don't necessarily need to push the stuff back. It's really just a stepping stone to next week where we'll do some stuff with classes and objects. So we're going to go to the link, which is this one here, exfiltratR. I'm going to clone it. Remember, when we clone like this, typing this in, we are cloning to our local machine whatever that repository is. We're not making a copy of it on a remote server, only on this local machine. And that's really important, because if we don't have access to that machine, we don't have the permissions to push things back, we won't be allowed to. So technically it's exactly what permissions are, I suppose, but you know what I mean. You won't be allowed to push it back to the server because this is not yours. It is mine, and therefore you don't have the rights to push things back. But here we go. We have exfiltratR, and the thing that we always do with these, because we're working on projects that include requirements for libraries and stuff, is we have a virtual environment and we have a bunch of requirements that we want to install into that. So we just activate those things now. So make them. And remember that these make commands, these are just my shortcuts for you. So you can see what it actually does is this. So always pay attention to those because they're useful. You won't always have a make file. If you're building your own thing, you can make a make file based on mine if you want to, or just type the commands in. Now I'm going to activate it. And one of the reasons that I gave everyone a virtual machine that defaults to using Z shell is that Z shell shows you a lot of information. One of the things it shows you is that we're inside the venv. So we're going to make prerequisites. So make prereqs. And again, you can see all this is doing is pip install -r requirements.txt. That's just a list of things to install. And now it's off and doing it. That's done. We also, on this one, we need to make keys because we're going to be using SSL. So this will generate a set of keys inside the keys directory. And these are the same as the keys that you would have on web servers. So you've got a certificate and you have a key. The key is used to create this certificate by signing things and what have you. And it just means that you can have a connection to the remote server that is encrypted. And if you know what that certificate and key are on the other side, you can also verify that it's the right person. So not just that it's encrypted, but it's the right endpoint that you're speaking to. Okay, so with that, with all of our basics, you can also always do make test and run any tests that are in there. There are no tests at the moment. There's actually one that you expected to complete at some point, so you can go through and have a look at that. It's sort of some boilerplate in there for you, but there we go. So what do we need to do? Let's have a look inside the source code. So exfiltratR source, and we have Alice and Bob. So these are our two communicating entities. So here you go. This is Bob. Again, you don't need to edit Bob in this case, at least not at the moment. You can always do more with it if you want to, but the real thing is xAlice. And this is about as small as I could make a functioning exfiltratR that uses SSL HTTPS requests to get data out. Okay, and the only reason I can do that is because I put the ugly stuff in here. Okay, so this is a thing that's actually dealing with parsing the requests. This itself isn't so complex. It's just a bit more fiddly than you're used to yet. So feel free to have a look through. A lot of it is even just documentation in some cases, but have a look if you want to. It's just not a requirement. Okay. The bit that we're expected to work on is the bit here that says needs to take query string like, and it gives an example, and return a dictionary of data. So what we're going to do is we're going to be taking stuff like this, which is the stuff you would find on the end of a GET request. So Google as an example, like this. So you can see on the end of there is a whole bunch of stuff that gets passed in, and they're separated by ampersands. So you've got question mark will go at the start, then you have the name of something, and then an equals, and then its value, then an ampersand, a name equals value. Like how we've seen dictionaries and things, so we were talking about earlier, you have a key and a value. It's just that now instead of the Python notation that we normally use, it's this. So data equals this, and stuff equals this, and age equals the other, right? So what we want is to take that, which will come in as a string, just a string of data, and we want to turn it into an actual dictionary of things. So that example there needs to become a dictionary that might be represented by this text here. So data is cheese, stuff is nonsense, age is, there we go, 41. So it also says doc strings and tests are required, so they're not written yet. There is an intermediate challenge which says that any value that looks like a number should be made into a number. We'll leave that bit out for now. We'll talk about it if we've got time in a second. Okay, so how I would go about this, if it was just me, is not the way I would expect you to go about it, because like we've discussed many times, I do terrible things with dictionary and list comprehension, and I think it's not helpful in this case. What I would do is I would look first and say, well, I know that the first thing I have to do is to break it up into these three chunks. And if you look, I have some information there, that's one pair, then an and, some information, and then an and. Well, we know that we have a really useful thing in Python called split. So Q, which is the data that's coming in, and we can see that here, so it's named Q. And when it's used, for example, down here somewhere, there we go, split query, data query, that gets passed into this and is now called Q, and so we can do something with it. So Q.split around ampersand will give us our pieces. Okay, so I might just call this pieces or chunks, or I call it I don't know, pairs or something like that, whatever name we want to choose. But each one of the things that come out of here is going to be one of these chunks, now being a list. So what we expect at this stage is that pieces will contain a list that looks something like data equals cheese, and then stuff equals nonsense.
James, sorry to interrupt you. Just
Yeah.
a quick question. When it comes to the URL, might be a silly question, but it's always going to be ampersand in the URL, isn't it?
Yes, that's part of the specification for how this stuff works. So we don't get to change that. I mean, I suppose technically we could put something else on the end and do it, but like no browser will understand what's going on with that. No server is going to likely to understand what it is. Since we're writing both, I suppose we could get away with it, but it just seems like a silly thing to do when there are standards for it. And also, in this case, we're trying to not look suspicious. So we want to stick to the standards as much as we possibly can. Right, so now what we'd expect in there is to have these pieces. And what we want instead is to have these as dictionary items rather than just strings that say something equals something. So we're going to make a dictionary. I'm going to call it D for now. And for each of these pieces, so for piece in pieces or P in pieces or whatever we want to call it, we're going to do something. All right, so what we're going to do is we're going to split again, but now we're going to get data equals cheese the first time round, stuff equals nonsense the second time round, and age equals 41. So we're splitting now around the equal sign instead. So I might say components equals piece. So piece will be each of, sorry, I pointed at the screen, not Dan did then. Each of these in turn. So piece dot split, and we're going to split around the equals. So now we have, hopefully two components. We could do a bit of checking here. So we could say if len components is equal to 2, my bracket, then we will say D. And as we talked about earlier, when we add new things to a dictionary, all we need to do is put whatever the key is here and whatever the value is here. Well, the key and the value are both parts of components, and this will, again, it'll be a list, and hopefully now it's a list of two pieces. In the first case, the first one will be data and then cheese. The next time it goes around the loop, it'll be stuff and nonsense in the two places, and then aged in 41. So hopefully we can just simply say that was a lot to delete. Components 0 is equal to components 1. And then we run through, that takes us through each of these in turn. And so at the end, we should have exactly this dictionary like that. So put that in comments, that's just so we know what we expect it to look like. And so we can return it. So we can return that dictionary D. What I would do to test this, just first run through would be, I would actually say, print D, and I would run it and see what happens, right? So I'd expect to see those results there. But longer term, what I really want is to have some tests. Okay. Something like this. Okay. So raw data equals thing equals what's it and height equals 120. Components, so this is the split query function that we just written equals that. Now let's make some assertions. Well, assert. Well, we can assert that thing is in components. Yeah. We can assert that height in components. Like this. And also, we can do some other stuff. So just let me switch to Python and show you what I'm thinking on. Now, if I have a dictionary, and inside that dictionary I say that we have, let's say, thing equals what's it, because that was their little example there. Okay, so thing in A is true. What does what's it give us? Okay, now notice the interesting thing here, thing and what's it are both in A in a sense, but the in operator here is actually saying, is this a key? Okay, it's not searching through all the values, it's searching through the keys. So that's something that we can actually use to help us put this test a little bit further along and say, well, if we make a mistake, there's a chance we'll end up with what's it in there. Okay, so let's assert not.
So James, what you've just described there, so unless you actually call for the value to be checked, it's always going to say, it's only ever going to look at the key in the dictionary. Is that correct?
Exactly. So when I say what's it in A, it's going to go, yeah, that key doesn't exist. That's all it's saying. It's not saying there's no value, call that. If we wanted to check the other way around, we also have things like a.keys, like this, which gives us the dict keys list, so we can actually turn that to be a list. We can find the length of those things. So here we have one, but we can also do a.values. So we can find the length of that, and we should, I think, be able to do. Okay, so we can check to see whether it's actually in the values from there as well. Okay, so let's try that. Okay, so now we can check that those things are in there, and the other thing that we should do, we should really check the length of those things. So assert length of components.keys is equal to 2. Okay. So there's that. I think this is a good starting point. If I was doing this in production code, I would also have this same thing pretty much again, but I would have something with no data in it. So I would go, right, let's do all of this again, but this time let's give it nothing. So assert that that's not in there, that that's not in there. Oops. That's not in there, that's not in there, that this is equal to 0 and that's equal to 0. I should put something to 2 at the end. I would also do it for one item and so on and so on and so on. I'm not going to go through and do them all now, because actually just testing that one thing should really be quite an extensive suite of tests if this was in production. Right, I'm going to pull this seconds for now, so I'm going to have to take this call, and I will be back shortly. Hello. Right, so should I quickly run that test to see if we got it right? There we go. So,
right. I'm going to say goodbye to you guys because I'm going to go grab something to eat before my lecture.
yes.
See you later,
now,
Daniel.
See you later.
Adam.
See you later.
I'll catch you in a bit.
Yeah, I'll see you
Jamie,
soon, mate.
etc. But I'm going to go and grab something to eat.
Take
Okay,
care.
cool. Take care.
Ciao for now.
So, as you can see, somewhere I've written annoying instead of not. There we go. So we passed. It says, you know, one item. You know, so it's not really telling us a huge amount. One of the things that you can do is you can split these things up if you want to. So you do things like this. So now I've got test split query, test split query empty, and if this is going to be like in production code, you might have tests for all kinds of things. I pressed a key there, haven't there? So now you can see what it is, and if something breaks, you get a better idea of which sort of category of things are broken. If it was production, I'd have loads of these to make sure it worked with all different kinds of characters. It worked with Unicode that was valid. It worked with things of you know, very long things, very short things. I'd make sure it worked with lots of items, few items, things that are corrupt. You know, does it fail properly? Does it fail in the right way? So you could do hundreds of tests just on that one thing, but not usually required for coursework. Okay, I need to stop recording.